Industry 4.0 is not the goal. Running better is the goal. That distinction matters because companies start with the wrong question. They ask, what technology should we buy? But the better question is, what operating problem are we trying to solve? A robot can be useful, a dashboard can be useful, and artificial intelligence can be useful as well. But none of them matter if the operation doesn't improve. If service doesn't improve, if the cost doesn't move, if quality is still unstable, if the warehouse still waits, and if transportation still reacts late, then the technology is not transforming the business. In this episode, we define the model behind Industry 4.0, not as buzzword, not as vendor pitch, not as a collection of tools, as a practical operating model from factory to delivery. In episode 0, we introduced the idea of Industry 4.0 from factory to delivery. We talk about why operations cannot stop at the factory door. A production line can perform well, but if the warehouse is not ready, the order still ships late. A distribution center can pick fast, but if transportation is not coordinated, the customer still waits. Today, we are not repeating that roadmap. Today, we define the operating model. We will look at 5 different things: the physical world, the cyber world, the Internet of Things IoT bridge, the execution loop, and the business outcomes. Then, we will connect that to the company tools that make this practical: maturity assessment, unit case portfolio, IT/OT architecture, KPI and data dictionary, benefits register, and deployment playbook. Not in full detail today. That would be kind of a workshop, not an episode. Today, the goal is simple: understand the model. Here is the practical definition. Industry 4.0 is a connected operating model. It integrates automation, digitalization, Internet of Things, data, people, governance, and standard work. And it does that for a reason: to improve business performance from factory to delivery. That means Industry 4.0 is not about the plan. It connects planning, sourcing, manufacturing, warehousing, distribution, transportation, and returns. It also means that Industry 4.0 is not only technical. It includes how decisions are made, who owned the processes, how exceptions are escalated, how benefits are measured, and how the solution is supported after launch. A smart system that nobody owns, it is not a smart system. It is just another tool waiting to decay. So, in this series, we will treat Industry 4.0 as an operating model, not a catalog, not a campaign, not a dashboard collection, an operating model. Digitalization versus automation. This is where many companies get confused. Digitalization, automation, and Industry 4.0 are related, but they are not the same thing. Digitalization means turning work, information, and processes into usable data and digital workflows. A paper checklist becomes a digital record. A manual report becomes live information. A disconnected transaction becomes a traceability issue. Automation, on the other hand, means using technology to execute a task with less manual effort. A conveyor moves, a robot performs a motion, a system triggers an alert, a scanner confirms a movement. Industry 4.0 is the next step. It connects digitalization and automation into one operating model. The machine sends a signal. The system understands the context. The workflow then triggers the response, and the person or the machine acts. Finally, the operation learns from the result. That connection is the difference between having digital tools and running a smart operation. Physical world, the automation pyramid. Let's start with the physical world. A smart factory is not one system. It is a stack of levels that need to work together. At the bottom, you have the field level. Devices, actuators, sensors, scanners, machine vision, and instrumentation. This is where the operation is measured, observed, and physically affected. Above that, you have the control level. PLCs, DCS, machine controllers, and control loops. This is where the equipment behavior is controlled. Above that, you have the supervisory level. SCADA, historians, HMI, shop floor monitoring. This is where the process is monitored, visualized, and recorded. Then comes the planning level. MES, MOM, scheduling, quality, maintenance, and warehouse execution. This is where business plans become operational execution. And at the top, you have the management level. ERP, business planning, logistics, finance, and customer service. Industry 4.0 happens when all these layers stop acting like silos and start working as one execution system. Cyber world, the digitalization pyramid. Now, look at the cyber world. This is the digitalization pyramid and also has layers. At the base, you need cybersecurity, not as an approval at the end, but as the foundation. If the operation is connected, it also must be protected. Above that, you need data storage and data structures. We mean physical servers, cloud database, historians, data lakes. This is where operational information is stored, organized, and made usable. Then come operating systems and platforms like edge, cloud, middleware, APIs, workflow platforms. Above that, commercial application and software as a service. We talk about ERP, MES, WMS, TMS, QMS, and CMMS. Then, customized applications for specific operating problems. Then, no-code and low-code tools, useful for speed but dangerous without governance. Then, virtual robots like RPA bots that execute repetitive digital tasks. And at the top, AI, generative AI, digital twins, simulation, 5G, and advanced analytics. The mistake is jumping to the top before the foundation is stable. AI on weak data is not intelligence. It is expensive guessing. Internet of Things breach. connecting physical signals to digital action. The bridge between both worlds is Internet of Things, more specifically, industrial Internet of Things. But don't think about IoT as a gadget story. Don't think about it as a sensor shopping list. Think about it as the connection between physical signals and operational decisions. For example, a sensor captures a condition. A PLC or a machine controller creates an event. A scanner confirms a movement, and its gateway collects the signal. A platform adds context. A workflow triggers action. That action may go to an operator. It may go to a supervisor. It may go to MES, WMS, TMS, or ERP. And in some cases, it may go back to the machine. This is how a physical event becomes trusted data. And this is how trusted data becomes action. But the bridge only works if it is secure, contextualized, and useful. Connected noise is still noise. Factory to delivery. The value chain is bigger than the plant. Plan, source, make, store, move, deliver, and return. That is the operating chain we need to improve. If planning is wrong, the factory reacts late. If sourcing is unstable, production suffers. If manufacturing performs well, but storage is not ready, the flow will be broken anyway. If the warehouse picks fast, but transportation is not coordinated, the customer will still wait. If returns are disconnected, quality problems come back as surprises. This is why factory-only thinking is not enough. A smart factory can still fail the customer if the warehouse, distribution center, and transport plant are not connected. So, Industry 4.0 must be designed for the full chain, not only to make production look modern, but to make execution more reliable, from planning to customer delivery. Closed-loop execution, sense, decide, act, and learn. The operating loop is simple. Sense, decide, act, and learn. Sense means the operation captures what is happening. Machines, materials, orders, inventory, quality, labor, transportation, and exceptions. Decide means that the system or the operating team understand what action is needed. Not just what happened, what action is required. Act means something changes. A schedule is adjusted, a machine is serviced, a shipment is expedited, a route is changed, inventory is replenished, labor is reallocated. Learn means the operation improves from what happened. The same exception should not surprise the business every week. This is why dashboards are not enough. A dashboard creates visibility, but without ownership, escalation, standard work, and follow-up, visibility doesn't become control. Data only matters when it improves a decision and changes an action. Maturity ladder. Industry 4.0 maturity is a ladder, and the order matters. The first level is fragmented. Processes, systems, and data are disconnected. Decisions are manual and very, very reactive. The second level is visible. The company can see more of the operation. Dashboard exists, data exists, but a response is still inconsistent. The third level is controlled. Standard work, governance, and basic integration create consistent execution in priority areas. The fourth level is orchestrated. Manufacturing, warehouse, transport, planning, and support functions start working as one system. The fifth level is adaptive. The operation can predict, recommend, and in selected cases, act with more autonomy. The mistake is jumping to autonomy before visibility and control are stable. Advanced technology on weak processes foundation is still a weak process, just more expensive. New solution implementation, disciplines, supply chain, and product life cycle. New solution implementation is not one-dimensional. A smart manufacturing solution has to work across three axes. The first one is the disciplines, mechanics, electronics, software, services, cybersecurity, data, operations, and logistics. The second is the supply chain. Suppliers, service providers, original equipment manufacturers, warehouses, distribution centers, transportation partners, and customers. And the third one is the product life cycle. Requirement definition, product planning, development, process planning, production, operation, maintenance, return, circularity. A solution that works only in one discipline usually fails in execution. If it only works for engineering, operations will struggle. If it only works for production, logistics will struggle. If it only works for one side, the network will struggle. This is why implementation design matters as much as technology selection. Why companies fail. Most companies do not fail because they lack technology. They fail because the transformation is disconnected. Systems don't talk. Data cannot be trusted. Pilots stay isolated. Users do not adapt the new process. There is no support model. Nobody owns the decision routine. So, the company has reports everywhere, projects everywhere, applications everywhere. But the operating chain still doesn't move as one system. A planned pilot may look successful inside one department, but when it is time to scale, problems appear. The cyber risk was not reviewed, the data owner was not defined, the KPI formula is debated, the interface is one-off. The support team was never prepared. The operators were trained once and then left alone. This is not Industry 4.0. This is fragmentations with better screens, transformation enablers, and lighthouse logic. Architecture alone doesn't scale transformation. The management layer matters. A successful transformation needs 6 things. First, digital strategy and targets. What outcomes are we trying to improve? Second, organization structure. Who owns the transformation? Who owns the execution? Who supports it after go live? Third, a test and learn approach. Not random pilots, disciplined learning. Fourth, talent and capabilities. People need to understand the new way of working, the new normal. Fifth, ecosystems leverage. Partners, vendors, technology providers, and internal experts. Sixth, the culture change. And I cannot emphasize this much, the culture change. Because the tool only works when people actually use it. The World Economic Forum Global Lighthouse Network is a useful benchmark. The point is not to copy one company. The point is to understand the pattern, scale impact, frontline adoption, resilience, sustainability, and enterprise capability. Industry 4.0 is not just a systems project, it is a management system. Business outcomes and company tool preview. For leaders, the test is not whether the technology looks impressive. The test is whether it improves performance. Service, cost, cash, quality, speed, resilience, safety, sustainability, compliance, and customer experience. Those are the KPIs that will be important to us. You need to ask yourself, does it help deliver on time? Does it reduce the actual waste? Does it improve the inventory levels? Does it protect quality? Does it make a decision faster? Does it make the operation more resilient? If you cannot answer these questions, then that is not the proper way. This is where the framework becomes practical. A company needs an operating model, a maturity assessment to know where it stands, a use case portfolio to prioritize value because you cannot do everything at the same time, an IT/OT architecture blueprint to avoid one-off solutions, a KPI and data dictionary to define trusted measures, a cybersecurity by design checklist to protect connected operations, a benefit register to track real impact, and a deployment playbook to scale beyond pilots. Not all of that belongs in this episode, but we will explore this later. Today, we are defining the operating model. Later episodes will show how to govern it, measure it, integrate it, secure it, deploy it, and scale it. If an Industry 4.0 initiative cannot connect to a business outcome, it needs to be challenged. Executive takeaway and transition to episode 2. So let's be clear. Industry 4.0 is not a robot project. It is not a dashboard project. It is not an artificial intelligence experiment. It is not a software rollout. Those things can be part of it, but they are not the goal. The goal is the operating model, the connection between physical flow, digital signal, automated action, human decision, and organizational learning. That is how the operation can sense, decide, act, and learn. That is how factory, warehouse, transportation, and customer delivery start working as one integrated system, not looking modern, running better. In the next episode, we move from definition to leadership because Industry 4.0 doesn't scale through technology alone. It scales through governance, organization design, decision rights, funding discipline, standards, and leadership behavior. That is the CEO playbook, how leaders make Industry 4.0 scale from isolated projects to a real operating capability. This is inDStry, and this is Industry 4.0 from factory to delivery.